Alright, welcome back guys. We're doing 71, problem 71. We're doing the last problem for chapter 10 for the big review. Big question review we're doing for the exam. But yeah, problem 71 says, two flywheels of negligible mass and different radii are bonded together and rotate about a common axis, seen below. The smaller flywheel of radius 30 centimeters has a cord that has a pulling force of 50 newtons on it. What pulling force needs to be applied to the cord connecting the larger flywheel of radius 50 centimeters such that the combination does not rotate? That combination does not rotate. So, interesting. Let's see. So let's go ahead and write down everything we know. We know that this looks to be like a disk, but let's write out the radiuses. We have the radius of the outer, so r sub o, that is 50 centimeters or 0.5 meters. And then we have the radius of the inner, which is r sub I, and that is 0.3 meters. And then we have the force acting on a cord that's pulling the inner disc. Let's see, the inner flywheel is what it's called. And let's go ahead and write F sub I for the force of the inner flywheel, and that is equal to 50 newtons. So it's saying they have negligible mass. And they rotate about a common axis. According to the larger flywheel of radius 50 centimeters, such a combination does not rotate. Oh, okay. So we are going to find out. We're going to have to use a. This seems to be an energy problem. So let's just go ahead and look at our formula sheet and see what we can find. So, let's see. So the change in kinetic energy, we obviously don't want it to rotate, so we want omega to be 0. You know what, this could be a torque problem, actually. That would make more sense. So let's just go ahead and treat this like a torque problem. If there is a torque on the entire body, then it's going to rotate, right? And it's giving us an inner and outer radius and a force. So that seems to be like a torque problem. So let's go ahead and treat it like one. So we're going to use the equation here. The equation torque equals R cross F. And we can look at the cross product for you guys if you're confused on that. Well, hopefully it makes sense. It's pretty straightforward. So yeah, let's go ahead and find out what the torque is on the outer disc, the outer flywheel, because we're given a force. So let's go ahead and do that. Ooh, I don't know why it zooms in when I do that. So we'll go ahead and find the torque of the outer flywheel. We'll call it T sub O, sorry, not I, T sub O, and this is going to equal radius of the outer, which is 0.5, and then cross. See, this is why we got rid of this multiplication sign. Remember we used to use this in rudimentary maths? It's gone now because we have cross products. Anyway, and then our force is 50 newtons. So, since these ropes are being pulled tangential to the axis of rotation, we can say that we don't need to find out what the angle is, because it's going to be sine of 90, and sine of 90 is 1, so it'd just be sine of 90 times the product of these two quantities. So we can just treat it as a simple multiplication problem. which is what it would be if it was if it's tangential. So let's go ahead and do that. Half of 50, half of 50 is 25, so we conclude that the torque on the outer flywheel is 25, and I forgot, torque is work, so it'd be Newton meters. I was about to say I forgot the units, but I think that's fair. I don't know why I would forget. It's radius times newtons, yeah. Radius times force. So that's the torque on the outer flywheel. And in order to have no rotation happen, we have to get the same amount of torque on the inner flywheel. Ooh, we did this completely wrong. That sucks. That really sucks. 50 newtons times the inner, not outer. Not a big deal. That's the kind of stuff that'll get you on the exam. You just gotta pay attention. But yeah, this is going to be the inner torque. I knew I should have wrote I. Okay. So it's going to be, the inner is 0.3 meters. So let's go ahead and calculate that. Darn. It happens. So the torque on the inner flywheel is 15 Newton meters. So we have to have the same torque on the outer flywheel. So yeah, we don't know the force, we do know the torque now. So we can just apply this same equation. So we'd write T tau sub O equals 0.5, because that's the radius, or that's the distance from the axis of rotation, and we're going to apply the cross product of the force, which is what we're trying to find. And when you do the cross product, it's the same as doing a regular product and then times the sine of the angle between them, of the axis of rotation and the tangential acceleration, I guess, or just like where you're applying the torque, sorry. And we see that that's 90 degrees. So sine of 90 is 1, and this just becomes a simple product. And we now know that it has to equal the same torque, and that torque is 15. So we can go ahead and divide both sides. Divide both sides by 0.5, and that's the same as multiplying 5/10. So if you divide by 5/10, you can say you're actually multiplying by 5 over 10, or 10 over 5. And 10 over 5 is 2. So we see indeed that the force is 30 newtons. And this force is on the outer. So yeah, that is how you solve this problem, problem 71. And again, it's pretty short, just like the last one, but it shows you how to find, how to balance torques so that there's no rotation on any given body. So yeah, thank you so much for watching. I hope my little error here didn't throw you off completely, but if you do have any issues, make sure to leave a comment down below and subscribe if you like my videos. And yeah, thank you so much for watching.